Welcome back, dear students. Today we are going to see the analysis and design of fixed beam. I will open the STAAD Pro. Okay, I will go with the new. I can go with the plain space, no problem. Analysis and design of fixed beam. I can save somewhere else here. You can save according to your folder. Then, as usual, I can follow this one. 1B. Here are the dimensions and the loadings. So I have three loads. Actually, this is one triangle load, this is UDL, and this is another triangle load. Triangle load 1 is 1 meter length. Triangle load 2 is 1 meter length from right side. And the remaining 3 meters we have UDL 4 kilonewton per meter and total length of the beam is 5 meter. As usual, we can create here total length of the beam is 5 meter. I can create 5 meter length of the beam. I can switch off the grid. 5 meter length of the beam is ready. Next, I will go here, general. Then I will create some property like a rectangle. Generally, wide is greater than ZD. I can create it as YT as 1 feet, 12 inches. The another is 9 inches. ZD, add, and I will assign this property to this. Assign. Next step is support. Click over the support. Create fixed support. This is the fixed beam. For this case, I can create a fixed supports here by using this create option. Then I assign over here using node cursor. Next is loads. I want to create the loads. Add. This time I don't want to add the self weight. Add. Close. Generally we will have self weight. We have to add it. But to understand how the member is reacting for the external loading condition, just assign only external loads. Say suppose one single point load, we can analyze it simply like member loads. I have a linear varying loads. Which kind of load I have? This kind of load I have two, and trapezoidal load, this kind of load. Which kind of load I have to use? Linear varying load, trapezoidal load. Generally, if I use this trapezoidal load, one side is 0 and another side is 4 from the experiment. See, this side is 0, this side is 4. From where it is started? 0 to 1. 0 to 1, D1, D2. 0 to 1. Add. The another one is from other side. Here it is 4, 0, opposite, and it is from 4 to 5. 4, 0. This is 4 to 5. Add. The next one is UDL, uniform force. This is minus 4. And where it will start? 2, right? 2 to, from where? 1, right? Not 2. 1 to 4. 1 to 4. Add. I think here we didn't add minus. Actually, this is minus. Acting vertical downward. So we have to keep it as minus. Change. You assign to this member to understand how the load is acting. First load is acting here, and the second load is acting where it is acting, and the third load where it is acting. Right. The same thing what we have in the figure we developed here. Next step is analysis. Analyze, give this command and analyze the member, how the shear force and bending moment. Next is the design. Go to the concrete design, select IS456 and the commands like a beam only. We have only beam. Takeoff is nothing but total concrete. Okay, use this option and assign to the member. If we have columns, we have to use this column command also, design column, and assign to the column. We'll see in the subsequent classes. Then again go for analysis. Then you will see whether the member is designed or not. We have a concrete details here, 210, 210, even similar to the last case. Because of small loading, you can increase the load to understand how it will be, whether it is sufficient or not. Then post processing. In the post processing, you can see you can zoom it out like this, and this is the deflection, and this is bending moment. See here we have a positive and negative bending moment, and the suppose it is restricted. Earlier it is no restriction. Now we have a restriction on either side because of flexibility. Earlier it was simply supported, no restriction. I mean there is no opposition. Here we have a opposite force that will restrict the deflection. And shear force you can see here. You can switch off bending moment and you can see shear force, how it will be. Okay. We can stop here. We'll see in the next exercise in the next class. Thank you.